Bismillahirrahmanirrahim. Welcome to Dr. K's Academy. My name is Engineer Rahman Ali Khan. Let's start the part B of lecture number 14. So in this lecture, we will discuss in types in the contraction joint, construction joint, and slip joints. As we discussed in part A, the expansion joints. And last, we will discuss the jointing material and plinth contraction joint. So the joints induced in concrete structure to localize shrinkage moment are called contraction joint. So contraction joints acts as a plane of weakness where cracks are likely to form in a controlled manner. You can see in the figure. So these joints are localized the moment caused by shrinkage, ensuring that any cracking happens along the joint line rather than randomly across the concrete surface. So if contraction joints are not provided, the natural shrinkage of concrete can cause uncontrolled or random cracks, which may affect the appearance, durability, and strength of the structure. So contraction joint may be complete contraction joint, partial contraction joint, and dummy contraction joint. So complete contraction joint. So a complete contraction joint is a type of joints used in a thick concrete section to fully break the bond between adjacent concrete parts. The purpose to allow free shrinkage moments of each section without causing cracks or internal stress. So in this types of joints, the bond between the two adjacent concrete section is completely interrupted, meaning they can move slightly without pulling on each other. This is done by using a specific method during construction. So painting one face with the bitumen or by setting a waterproof paper or making the surface of one section smooth before casting the next adjacent section. Partial contraction joint. So a partial contraction joint is a type of joint in which reinforcement, you can see in the figure, or steel bars continues across the joint. So because of this continuous reinforcement, the joints does not fully separate the two concrete section, and only a small amount of movement is allowed. These joints are designed to control shrinkage cracks while still maintaining structure stability, meaning the section remain connected and can resist load together. Dummy joint. So a dummy joint is a type of contraction joint where a groove or a notch is made on the surface of the concrete to create a plane of weakness. You can see in the figure. Here is a groove or notch. So this groove is usually shallow and guides the location where the concrete will cracks uh, due to shrinkage, so that the cracking is controlled and neat. The groove can be made on one or both surfaces of the concrete, usually during finishing while the concrete is still fresh. Sliding joint. So the joints provided between the two parts, enabling their movements, and both the planes are known as sliding joints. So the surface of one part is made very smooth using plaster or terrazzo or bitumen material, and this smooth surface acts as a slip planes which reduce friction and allow the new concrete pour on top or beside it slides freely during movement. The second part is cast after the slip surface is prepared. So this type of joints provided to prevent a cracking or stress at the interface of two parts that move differently, and it is common in area where differential movement is expected. Construction joint. The joints are provided at location where a construction stops for any reason, and when their location does not coincide with the date of expansion or contraction joints are called construction joints. So these joints do not serve the purpose of handling movements caused by expansion or contraction. Instead, they are meant to reconnect fresh concrete with already hardened concrete and prevent movement at that location. So in this, no movement is allowed across construction joint. The two parts are expected to act as a single unit, and this strong bond is essential between the old and new concrete to ensure structural integrity, and special care is taken so the old surface is clean, roughened, and sometimes treated with bonding agents before new concrete is poured. So in case of slabs, beams, or girders, the construction joint should be provided at mid-span because the bending moment is high and but shear force is low at mid-span. So bonding between old and new concrete can be brick and shear. Placing joints where shear is minimal reduces the risk of failure. Joints and a column should be made at the underside of the floor. Placing the joint below the slabs helps in achieving better structure continuity and avoid weak points right at the heavily loaded slabs column junction. Jointing material. So the material used for forming and filling the joints and structures are known as jointing material. So these materials are used to seal joints to prevent the entry of water, dust, debris, or other foreign material that could damage the structure or reduce its lifespan. And it is used in joints like expansion or contraction joints. These materials allow the structure to expand or shrink due to temperature changes or moisture variation without cracking. And jointing material remain flexible and adhere well to concrete or other material, ensuring a long-lasting joint even under moment or stress. So types of jointing material are joint filler, sealing compound, water bar. We will discuss this in next slides. Joint filler. So the strip of a compressible material used to form and fill the expansion joints provided in a structure is known as joint filler. So joint filler may be bitumen material, cork strips, rubber, expanded plastic, mineral fibers, polythene foam, coconut pith. So we use this material to provide spare. So the function of a joint filler are to permit the components of the joints to expand without developing compressive stresses as a result of thermal and other charges. And the filler acts as a bracking material for sealing placed on top of joints. This helps the sealant maintain its position, shape, and effectiveness and sealing out water, dust, and debris. So requirement of a good joint filler are it must be cellular. The material should have a cellular or a sponge-like structure to ensure it can be easily compressed and regain its shapes when the pressure is reduced. It should have ability to recover 75% of its original thickness as soon as the pressure is released. It should be adequately durable. It should be resistant to termite effect, and should have sufficient rigidity during its handling and testing to permit formation of straight joints. So you can see here in the figure, this a joint which is filled by filler material. Sealing compound. So a material of plastic consistency applied to the joints in the form of liquid or paste is known as sealing compound. You can see in the figure, this is a joint which is filled by a liquid material. So the function of using sealing compound and joints are given below to seal the joints against the passage of water. So to avoid damage from moisture, corrosion, reinforcement, and weakening of the concrete. To prevent the entry of grits and other foreign matter into the joints. So it blocks the joints from dust, grit, debris, and insects, which could cause abrasion or clog the joints, reducing its effectiveness. To provide protection to the filler where necessary. So it shields the underlying joint filler material from weathering, from weather, UV rays, chemicals, and physical damage, helping the pillar last longer and perform better. Water bar. So a strip placed across the joints during construction so as form an impervious diaphragm is called water bar. You can see here this is a water bar which is provided in a joint. So it is also known as a water stopper, and it may be a natural or a synthetic rubber made from a flexible rubber material which provide excellent elasticity and water tightness. It can accommodate some joints movements without damage, and it may be a polyvinyl chloride or in short PVC. So it made from plastic strips which is durable resistance to chemical and weathering, and it often ribbed or with pans for better grip within concrete. And it may be a metal water bar, so which is made from metal like steels or copper, which is very strong and durable, and it is usually embedded in concrete joints for waterproofing in heavy duty structures, and it may require protection against corrosion. So the function of using water bar in joints are to shield the joints against water penetration and to resist the pressure of groundwater. So the requirement for a good water bar, it should have good flexibility, should be of large width, and should have low modulus of elasticity. Plane protection. So plane protection is a protective layer provided around the plane from the base parts of a building between the foundation and the ground floor level. So we provided the plane protection to prevent water penetration into foundation soil. So water penetration can reduce the soil bearing capacity, leading to uneven settlement or damage to the foundation. And to avoid water accumulation near the building. So by providing a hard slope surface, plant protection helps drain water away from the building, preventing water logging near the foundation. And it protects plant machinery from dampness. So the layer prevents moisture from rising into the plant machinery, uh, protecting it from dampness and reduce issue like molds or decay. So commonly, plant protection comprises a 3 to 4 inch thick and a 2.5 to 3 feet wide layer of plain cement concrete. I mean PCC of proportion 1:2:4, or 4 to 6 inch layer of lean provided all around the building. So a drain may be provided along the outer edge of plant protection. So plinth protection is a concrete layer around the base of the building that prevent water from damaging the foundation soil and plinth machinery by stopping water infiltration and directing surface water away from building.